Hi everyone, today we are going to solve a fourth order linear homogeneous equation with constant coefficients. Remember that the order of the equation is defined by the order of the highest derivative. It is 4 in this equation. Make sure to use parentheses for the order of the derivative, otherwise it will mean the power of y and this equation will be nonlinear. This is a homogeneous equation since we have a 0 on the right hand side, there is no function of x. And we have constant coefficients. The coefficients are 1 in front of our derivatives. First step that we do is write the characteristic equation. A shortcut for memorizing it is to write r instead of y and the power of r instead of the order of the derivative. So if we have fourth order, we'll have r to the fourth, and second order gives us r squared equals 0. That is a pretty simple polynomial equation that we can solve by factoring. Factor out r squared and set each factor equals 0. We get first solution r squared equals 0, so r equals 0. Note, because of the square, this is a solution multiplicity 2. And setting the second factor equal to 0, we get r squared equals -1. So r equals plus or minus I. That is an imaginary number that you need to think of as 0 plus or minus I, since we need the real part of that imaginary number, which is 0, and the imaginary part, which is a 1. And we are pretty much done with this equation. The only thing left is to write the general solution. We get y equals first unknown constant c sub 1 e to the power of real solution 0 times x, plus, since this was a solution multiplicity 2, we are going to have a very similar term just multiplied by x. Next constant c sub 2 x e to power real solution times x, plus, since we have this imaginary solution, we will have e to the power of real part 0 times x times, in parentheses, next constant c sub 3 multiplied by cosine of the real part, which is a 1, times x. Or you can just write cosine x, plus our next constant c sub 4 sine of the real part 1 times x. Or simplifying our exponential expressions, we get c sub 1 plus c sub 2x plus, we don't need this, so we don't need parentheses, and we get c sub 3 cosine x plus c sub 4 sine x. And that is the general solution of our equation.